Hi all, in this lecture we will study proofs involving power set. So what is a power set? We have already seen that if you have a set A, then the power set of A, that is basically set of all subsets of A. So in this power set of A, you will have S where S is a subset of A. So this is the definition of power set. If you have a set A, for example, let's assume that your set A is A comma B, then in that case what will be the power set? Power set is a set. Power set is a set. So you can notice this is power set. Power set is a set. In this power set you have a subset of A. So for example, subset of A, phi is a subset of A, and you can notice that this is a subset of A, and this is also a subset of A, and also this A comma B, this is a subset of A. So this is the power set of A. So if this set A has two elements, then the power set will have total four elements, because for this set A there will be four subset. If you have a set A, let's assume you have a set A where the cardinality of set A is n, so there are n elements in the set A, then in that case how many subsets will be there? So the number of subsets of A, how many subsets will be there for A? That will be 2 power n, we have already seen. So the cardinality of power set of A, that also will be 2 power n, because in the power set we have all the subsets of A. Every element of power set is basically a subset of A. Okay, so this is the idea. Now let's see what are the things that you, whenever you have any theorem, whenever you have any statement related to power set, okay, then what are the tools that you will need? So first tool that you will need is this concept that every element in the power set is basically subset of A. So this is the first concept, that every element in power set of A is basically subset of A. That is the definition, that is by the definition, because in the power set of A, okay, every element that we have, that element is basically subset of A. So that is the concept. I can say, okay, remember, I can say that if X belongs to power set of A, then what it means? Then it means that X is a subset of A. So this is the concept we will need. Also you can notice that if X is a subset of A, then of course it will belong to power set of A. So if X is subset of A, then it will belong to power set of A. So basically, okay, from these two I can say that X is a subset of A if and only if X belongs to power set of A. So this is very useful, many times we will use it. Okay, so if you say that X belongs to power set of A, it automatically means that X is basically subset of A, because in the power set of A you have subset of A. In the power set of A, every element is basically subset of A, and if X is subset of A, then X will belong to power set of A. So this is the statement we will use, that X is subset of A if and only if X belongs to power set of A. The second thing that we will use is basically phi belongs to every, okay, phi necessarily belongs to every power set. Phi always belongs to power set of any A. Okay, whatever set you take, for all set A. Okay, so if A is any set, then definitely phi will definitely belong to the power set. Okay, remember, A can be any set, I can say, because you know that phi is a subset of every set. Okay, phi is subset of A, for all set A. If A is any set, then phi is definitely subset of A. So I can say that in the power set of any set, definitely phi will be there. Okay, so phi, it belongs to power set of A for all set A. Okay, this will definitely happen. And you can also notice that for any set A, I can say that for any set A, we also know that A is subset of A. Every set is a subset of itself. So I can say that this set will also belong to power set of A. So these things, A will always belong to power set of A, and also phi will always belong to power set of A. So these two elements are definitely belonging to power set of A. These definitely will be there. Okay, the third point, you can notice that every element in power set is basically a set. Okay, because what we have in power set, every element is basically subset of A. Or I can say in power set every element is a set. Okay, so for example, you can notice that if this example we have already seen. For example, here you can notice this is the power set of A. In this power set of A, every element is a set. This is a set, this is a set, this is a set, this is a set. So you can notice in the power set, every element is a set. So what I can say? I can say that if you know that X belongs to power set of any set, then what you can say? Then you can say that X is a set. Then you can say X is a set. Okay, X can be empty set, but the point is X is a set. Remember, X can be empty set because in the power set you definitely have empty set. But the point is X must be a set. Okay, for example, now you can say that X can never be 1. Okay, X can be this, X can be this because X must be a set. So you can say X can never be this one, X can be a set, X will always be a set. Okay, so this is the idea. For example, X can never be, I can say for example, okay, X can never be A. X can be X is always a set. So this is the idea. X can be 5, but the point is X must be a set. Okay, so every element in power set is basically a set. And the last point that we will use is basically, if you know, okay, that let's assume if you know that X belongs to power set of A, then what you can say from this, what you will two things you will see that, okay, if X belongs to power set of A, then first thing is X is a subset of A. Okay, and the second thing is X itself is a set, and the second thing is X itself is a set. Remember, this X can be empty set. I am not saying that X must have element. X can be empty set. Okay, but the point is X must be a set. Okay, X cannot be a normal element, like X cannot be this element. X should be a set. X must be a set. X cannot be this element, but X should be a set. Okay, so this is the point. If X belongs to power set of A, then you can say that X is a subset of A. Now if you want to prove, okay, that X, if you want to prove, let's assume you want to prove that X belongs to power set of A. If you want to prove this, then what you have to do, then what you have to prove, then basically show that, then what we have to show, we have to show that X is a subset of A. So if you want to prove that X belongs to power set of A, then you have to prove that X is a subset of A. Similarly, if you want to prove, okay, if you know, okay, so for similarly, if you already know that X is a subset of A, then I can directly say that X definitely belongs to power set of A. So these are few ideas that you can use basically when you see any statement involving the power set. Okay, so let's see this question. So anyway, this is just the concept that what is the definition of power set, you already know. This is the set of subsets of S. So power set of S is basically set of all subsets of S. In the power set of S, you have every element is subset of S. If you want to prove that some element belongs to power set of S, then you have to prove that T is a subset of S. And if you know that T belongs to power set of S, then you can conclude that T is a subset of S. Let's solve this question. For any set A comma B, okay, show that we have A intersection B equal to A if and only if A belongs to power set of B. So this is the concept. So here basically this is what we need to prove. We need to prove that, this is what we need to prove, that A intersection B is equal to B, okay, is equal to A. A intersection B is equal to A if and only if, okay, A belongs to power set of B. So basically two things we have to prove here. This is the if and only if, means we have to prove two directions. We have to prove that, okay, that if this is true, then this should be true, and also if this is true, okay, the another direction that we have to prove is basically if this is true, then this should be true. So these two directions we have to prove. Okay, so let's prove these two directions. So first I will prove that, okay, I will prove this direction, means if A is a subset of, if A intersection B is A, okay, then it means A must be a subset of, then A must be a subset, power, A must belong to power set of B. Okay, so this is a power set of B. Now here you can use the idea that we are discussing. So if you want, basically what you want to prove, okay, so if you, this is what we want to prove. So this is the given thing, okay, from this, if this is true, then we want to prove this. Okay, so if A intersection B is A, then this is what we want to prove, that A should belong to power set of B. Actually what this means, this simply means that A is a subset of B. So actually what we need to prove, this is the idea. A belongs to power set of B, it means simply that A is a subset of B. So actually what we need to prove is this, that if A intersection B is equal to A, then it means that A is a subset of B. This is what we need to prove. Because if we can prove this, then it means A is a subset of B. It automatically means that A belongs to a power set of B. So let's see this. If A intersection B is equal to A, what this means? This simply means that, okay, so it simply means that every the all the common elements, okay, what it simply means, what is A intersection B? A intersection B basically means that that is the common elements of A comma B. So if this is A, if this is B, let's assume this is A, this is B, then this area is basically the intersection area. This area is intersection area. Now we are saying that this intersection area is equal to A. Okay, when it can happen, the intersection area is equal to A, means the common area, means every element of A is also in B. This is the idea. Okay, so this can only happen in this situation. In this situation it can happen. So basically I can say that if A intersection B is equal to A, what it means? It means that the common elements of A comma B, that is same as A. Okay, it means that all the elements of A are already in B. Yes or no? Correct? Okay, because the common elements of A comma B, that is equal to A. It means all the elements of A are already in B. Okay, every element of A is in B. So this is the idea. Okay, so I can say that every element of A is in B. What it means? It simply means that A is a subset of B, and A is subset of B. It automatically means that A belongs to power set of B. So this direction we have proven. Okay, so this first one we have proven. Let's see the second one. The second direction that we have to prove is if A belongs to power set of B, if A belongs to power set of B, then okay, then this is what we need to prove. Then we need to prove that A intersection B is equal to A. So what this means, first of all, okay, A belongs to power set of B. This simply means that A is a subset of B. Okay, so this is the idea. This A belongs to power set of B. It means that A is a subset of B. Now, if A is a subset of B, remember this is A, okay, and this is B. So if A is a subset of B, every element of A is in B, then what will be the intersection? So from this, what will be the intersection of A comma B? The intersection of A comma B, the common area of A comma B, that will be basically A. So this is what we wanted to prove. So this is the, okay, so this is the second. So the second direction also we have proven. So we have proven this direction also, we have proven this direction also. So finally I can say that this statement we have proven. Okay, so for any set A comma B, we have proven that A intersection B is equal to A if and only if A belongs to power set of B. Okay, so this is how very easily you can handle the questions related to power set. Now read these two questions. Okay, suppose A comma B are set. Show that power set of A intersection, okay, power set of A intersection power set of B is equal to power set of A intersection B. Show that if two set you have, then power set of A is subset of power set of B, then A is subset of B. These two statements we need to prove. Okay, so you can think about it, you can try to prove them, and in the next video we will prove them. Okay, so these two questions you can take as homework right now, and the solution will be available, the proof will be available in the next video. Okay.